Hi, I'm Alfredo. I am an Italian chemistry teacher. I would be pleased to help you understanding every bit of chemistry you need and you ask me. And it could be about any topic about general chemistry, inorganic chemistry, organic chemistry, analytical chemistry, as well as physical chemistry. And at the same time, you would help me to improve my English communication, and that could be free for both. Um, I want to show you now how a lesson could be about titration, about calculation with moles. Moles could be uh, it is a topic of general chemistry, titration, and similar sort of things. And some students of mine have did this experiment, and in which they put some 2 grams of a carbonate of an unknown metal. This 2 grams was put to react with hydrochloric acid, and in this reaction some CO2, carbon dioxide, was developed, and we can write a reaction. Okay, we try. This is a generic formula of an unknown metal carbonate, and that reacted with hydrochloric acid, and CO2 was evolved, and another salt remained dissolved. That was the chloride of the metal. So we have this kind of chloride dissolved. Okay, and the students weighted the total mass of before of the reaction and after the reaction, and determined by subtracting the second from the first. They determined the total amount of carbon dioxide that was formed, and then they titrated the quantity, the amount of hydrochloric acid that remained in excess at the end of the reaction, using sodium hydroxide 1 molar, and they used 21 milliliters. And now they have to calculate the amount of hydrochloric acid that reacted with the carbonate in the first step. And we need to balance this reaction, putting this coefficient. Okay, now the reaction is balanced. Not properly, because we need to add some water here. Okay, now is balanced. Well, for the calculation, we have to know, as the students knew, that the hydrochloric acid that they used, that was exactly 10 milliliters, with molarity that was 1 to 1, had molarity 5.952 moles per milliliter per liter, and this amount equals to 5.952 millimoles per milliliter. Is the same way to express the same concentration. So if they used 10 milliliters, this means that they added 10 milliliters 5.952 millimoles for each milliliter. So the total amount of hydrochloric acid that was added in the beginning of the reaction was 59.52 millimoles. Well, okay, now the amount of sodium hydroxide that was used for the titration was 21.1 milliliters of NaOH, 1 exactly 1 molar, 1 mole per liter. That means is the same of 1 mole, 1 millimole per milliliter. So we have in 21 milliliters, we have this amount of 21.1 millimoles. Okay, now we know the quantity, the amount of hydrochloric acid that was added in the first, and we know the amount of hydrochloric acid that remained at the end of the reaction, after the reaction. So we can simply calculate the quantity of hydrochloric acid that reacted with the carbonate in the reaction as the difference of subtracting the initial from the initial quantity 52, the remaining quantity, that is equal to 38.42 millimoles. Okay, and this quantity can be put in relation with the quantity of carbonate, because from the balanced reaction equation we see that each mole of carbonate reacts with 2 moles of hydrochloric acid. So the amount of carbonate should be the half part of that. So we have the amount of carbonate is the half part reacted (38.42 millimoles divided by 2 equal 19.21 millimoles. Okay, now we know that this amount corresponds to 2 grams, exactly weighted by the students. And so we can express this in milligrams. 2000 milligrams divided by 19.2 millimoles, we can obtain the milligram that corresponds to each millimole, and that we can get with a simple calculation. Two thousand 19.21 104. This is the molar mass, grams per mole, the molar mass of the unknown carbonate. Okay, we can see that this data is close to the molar mass of calcium carbonate. The formula weight is around 100, while the molar mass of sodium carbonate is around 106. So they have to match this experimental data from the mass of the CO2 to decide if the unknown carbonate is closer to the calcium carbonate or to the sodium carbonate, or to make some different investigation starting from the sample. Okay, I want to show you, I want to say you that this example was for the third grade students, so it was a little bit advanced. If you want any information about something less or higher, harder, please don't hesitate to call me. See you soon in WiZiQ.